In this video, I'll be working through the question you see on the screen here from the Maths Paper 1-3 from 2024 Cambridge A-Level exams. If you're looking for a different question from this paper, have a look in the description below. There should be a link to a playlist. And if you're looking for a different paper entirely, have a search on my channel. I'll be doing all this on a whiteboard, hopefully just like you're used to doing in the classroom. But remember, we're not in the classroom, we're on YouTube, so take advantage of that. Pause, rewind, even watch it at a different speed. If you find this video or any of my videos useful, I would greatly appreciate a like, a subscribe, a share, or even a super thanks. In question 4, we're given this trigonomic equation here, which I hope you can see. I know there's a bit of a shine on the screen there. Still, you should know what it looks like from your own questions. We're given this equation and we're asked to make it look like this one. Well, that's just something sine squared plus something sine plus something equals 0. This is quite common. We're asked to rearrange trigonomic functions, and it's quite hard to explain how it's done. You're given lots of equations to work from that you can use to rearrange this, make it look different. So it can be intimidating to know what to do. All I can say is practice, and I'll try and explain what my thinking is. So when I look at what I want all signs in it. But I see sine squared, and I'm already thinking in myself, I'll write it down here because we do end up using it. I'm already thinking that one of the most famous equations you use, cosine squared plus sine squared, or the other way around, is equal to 1. That's already in my head, and I'll leave it there because we will use it. And then I'm looking at this one here, how to turn this into sine. We have cosines, and we have tan. Well, tan jumps out at me. Another one of the most famous ones you'll use is tan is equal to sine over cosine. And I would say these are the most common two things you will use. In fact, pretty much everything is built on these two. So all those other ones build on this. So you can pretty much use these to do all of these questions. And that it works out in this case. First thing, so looking at this side, which is what I want to change to that, I just changed tan first. That's what would jump out at me. And I'd write it again. Cosine 7 sine over cosine minus 5 cosine theta. Still equals 1. And then we just have something multiplying in a bracket here. No reason not to multiply it in. And very conveniently, it would cancel. At least part of it. So we get 7 sine theta minus 5 cosine squared theta equals 1. Now, again, I see another squared. I'm jumping back to this equation. This equation, very famous, but also keep in mind the what happens when you move one of these over. I'll write it out here. Cosine squared theta will equal 1 minus sine squared theta. Or indeed, sine squared is equal 1 minus cosine. They come up all the time. If you don't want a cosine, and I don't, you can replace it with a sine squared, no problem. Cosine and sine can be replaced quite easily, especially when they're squared. So let's just change it. 7 sine theta minus 5 multiplied by 1 minus sine squared theta equals 1. Multiply this 5 in, let's see, we get minus 5 by minus sine squared, we'll get a plus 5 sine squared. Where will we get a sine? We'll only get 7 sine here, and there's one thing we didn't do, the minus 5 by the 1, it's minus 5, and that's it still equals 1. That's pretty much what they wanted. If we take 1 from both sides, minus 6 equals 0, and that is what we wanted. Something times sine squared, 5 is the something in this case, plus something times sine, 7 in this case is the b, and minus 6 is the c. Let me just double check that. Yeah, that's right. And yeah, that's it for part A. Part B, I'll rub out a lot of the board here, but pretty much they ask us to solve this equation. Although they changed theta out for 2x, you'll see in a moment. So of course we're not going to solve this, we're going to use this. So part B simply asks us to solve this equation here when x is between 0 and 180. We'll deal with that in a moment. So of course I'm not thinking of this, I'm thinking my answer from the first part. Instead of doing this, I'm thinking I want to solve, sorry, it should be 5 5 sine squared, whatever angles here, 2x in this case, plus 7 sine 2x and minus 6 equals 0. I want to solve that. That's a quadratic. I know how to solve quadratics. If you're not good at factorizing, especially when trigonomic functions are involved, use the minus b formula. But this does work out quite easily. The only factors of 5 are 5, and so that should be 2x. 2x. The examiner won't mind if you put theta in a lot once you fix your mistake near the end. Lots of students like using something simple. Like, I would advise not to use theta though, use some other level. A, B, C, anything you want. Sine 2x. So yeah, the only thing to make 5, if it's going to be even, if it's going to be nice and neat, is 5 and 1. How do you make 6 then? Well, 6 and 1 maybe, 2 and 3 maybe. Try them out, see which works. I believe 2 worked. 2 here gets 10 and 3. 10 and 3 can make 7, so 2 and 3. Let's see, we need a plus 10 and a minus 3. So we get the answer that sine 2x is equal 3 over 5, or sine 2x is equal minus 2. Now you need to keep an eye out for things like this. Sines can never equal minus 2. 2 sine can, but sine anything can't equal minus 2. This is an impossible answer. So you're nearly at your answer is this. Sine 2x is equal 3 over 4. At this point we're going to have to be really careful. Where will I put it? I'll put it down here. You can put this in your calculator and like 2x, inverse sine of both sides, and you'll get, let me write down what you'll get. Let me check here. You'll get this to be equal 36. I'll give myself plenty of room here. 36. But remember, your calculator is dumb. Sines look like this. There's lots of answers to a sine. This is 3 over 5. So the calculator will give you this answer. But there's lots of other answers. I've taken down a few of them here. Let's see. The other answers will be minus 216.9, 143.1. You're going to need these two, by the way. 396.9. You're going to need all these. At this point, students might say, oh, they told us the answer is between 0 and 180. So you get rid of that and these two. And that works. Annoyingly, that works in this question. But they didn't tell you 2x was between 0 and 180. So be very careful. That does not usually work. You're looking for x. So let's find x for everyone. This says going on forever. This says going on forever. Let's find x for all of them. I'll just jot these down now. 108.4 minus 108.4, 18.4, 71.6. I'm just dividing them all by 2. 198.4. Only when you get to the x can you use 0 to 180, and that's too small. That's okay. That's okay. That's too big. There are your two answers. If you want to eliminate on this line, you can't think 0 and 180 2 times that. You have to think between 0 and 360. So you can eliminate those ones there, leaving the same 2, sure, but doesn't always work out that nicely. Yeah, they're your answers there, these two. Okay, that's it for question 4. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching. Have a great day.